Yeah, thanks so much for having me on your podcast. So my name is Oliver Lang. I'm the co-founder and CEO of Intelligent City. We're based in Vancouver, Canada. We grew out of an architectural firm that we started almost 25 years ago, realizing a need in our industry to come up with an integrated approach to really rethink how we design, engineer, and deliver buildings to get to a product that we think really addresses some major issues and problems in our industry, and hopefully provides a path to just much better way of urban living. That was the vision when we started. We wanted to, from the beginning, when we initiated thinking, that's about 15 years ago, very much focus on making sure that our product that we can deliver is all about environmental issues and really get us to solutions that can be carbon neutral and have a model and a repeatable and scalable model to address the major housing issues that are in the world around choice, supply, quality, affordability. So really bringing these two things together, trying to address housing issues and getting us towards a path of carbon neutrality that motivated us. And we realized that what was missing in the industry was a path towards deep integration of design, engineering, and the use of advanced technologies. And so we've been pioneering the use of advanced software technology, of robotics, but also of the use of mass timber technology that we can apply for mid-rise urban housing, which is really our target. So how do we densify cities smartly for resilient communities, using a product that comes from a renewable resource, and then apply advanced technologies to that product so that we can have at the end an end product that people could really wholeheartedly embrace and that works well to smartly densify urban environments. So that's the motivation. So that said, we're really, by definition, we're a housing technology company that takes a product and platform-based approach. And we're seamlessly integrated, as I mentioned, like advanced software, robotics, and mass timber building systems for quality urban housing that can be built faster, more affordably, and consistently carbon neutral. So that's sort of in a nutshell, the vision.
Yeah, well, that's phenomenal. That's so exciting. I mean, there's a lot of layers to everything you said there, but I might just pick one of them. Firstly, on software. So what sort of software are you using in your, I guess, end-to-end solution that you've come up with?
Yeah, so we have basically in the end-to-end solution, we have different aspects of software that we've developed. On the front end, the software allows us to go quickly through iterations of design, but always on the basis of and full understanding of the entire systems that are underlying it. Right? So the software is co-evolved with the design of building system, of the manufacturing systems, building databases around everything. So when we go through a front-end modeling with the client in the early stages of a building, we can immediately have a live readout around, environmental performance data about carbon footprint and energy needs. We can get a readout about the number of homes, the mix of homes that you can have in a building, the overall size, the density yield on a building, but also qualitative aspects about livability, access to daylight, ventilation issues, and so forth. So all of this has been basically parametricized to inform buildings from the front end, so you can rapidly iterate through the design versions and sweet spot this so that clients don't run through this risky process of not knowing what they might get, but rather actually show them and demonstrate to them what the right response would be for their building, for their objectives on that particular site, based on the use and the knowledge that we have through our componentry, right? And so the software can't be thought of not existing directly in correlation with everything else. So that's the front end. Then we have the sort of like the midsection of the software. It's all about having a software reporting out and being collaborative in the industry, so that and that software is completely proprietary. We built that in-house, but it can link into what people do. So we collaborate, with structural engineers, trades, manufacturers, and so forth of other parts that we don't manufacture ourselves. And so the BIM compliance issues and being able to connect and collaborate with partners in the industry is very important. And then we have the back end of the software. And it's the main of software has also deep level of database integration, so that we can control everything. We always know quantities and carbon and all these things, energy performance. And then the back end of the software is then we take that model and we can read it out directly into the manufacturing automation. So the software generates the robot code so that we can manufacture our systems that we have.
I feel like that does sound quite different, because there has been others players in the past who've tried an end-to-end, solution. How is it different to other players in the past? And it might sound like you're an emergent sort of strategy you're playing, where you're connecting with others. So can you tell us a little bit about that? How you're going to evolve with this ecosystem?
Yeah, so I mean, the key thing for us was we didn't want to build, a piece of software that's sort of like a black box for broadest usage. We just said we want to have something that's extremely streamlined around the kind of buildings that we want to do, and we want to enable all the integration that is necessary. So we're constantly asking ourselves, how can we make things simpler, more efficient, less complex, while having access to all the critically important data and make that data really robust, right? So it's, as I said, I think what's really different is that we're not a software company. Our software is just part of a technology ecosystem that is constantly integrated over and over again, right? We're cycling back and forth from design, engineering, to building systems, to manufacturing, automation, into software, back through the process and so forth. So all these technology parts co-evolve with each other and couldn't in fact exist without each other.
Yeah, that's so cool. So you've got the end to end. You got robotics, and I have people listening right now, audio only. I've seen a presentation of yours, and it's insanely impressive and exciting. The robotics and the manufacturing. Can you tell us about that end to the solution, and how might that be different with the advantages that you've got, because you're one step below the supply chain compared to, say, suppliers which are supplying the material only, and how are you doing that side differently?
Yeah, so we chose, or we decided we would go on the side of robotics for some obvious reasons, which is that you can have repeatable processes execute fast. And so it's definitely a gain on time there. That's very, very important. But equally important is the possibility of quality control that you need to do when you come up with your own building systems. And we have, right? So our building systems are now certified for North American markets to have fire resistance. We're like the first that have basically a robotically assembled building system that you can build up to 18 stories tall, right? And it'll be fire resistant. To get there, you can't just think that you take a few pieces of mass timber and nail and glue them together. You have to put them together in ways that are completely controllable. And that's where the robotics come in, where we basically run, the protocols in such way that we know that the fire resistance is always ensured, that the acoustic performance is always ensured. We also, just to digress for a moment, we're manufacturer for understanding. We manufacture the superstructure of the building, so all the floor slabs. It's a hollow core cassette system that we can make in really large proportions, right? And a building envelope system also based on mass timber that always meets passive house requirements. So we have two robotic cells in the factory. One makes building envelope and makes superstructure components. And then we have a robotic milling center that takes basically raw CLT that we can buy off the global market and mills it to complete our specification and precision just in time for then the assembly of the manufacturing of these large scale components, right? So speed matters, quality control to even enable to have systems of this kind that can perform like this consistently matters. And thirdly, adaptability matters, because the beauty of a robotic execution code is that it can vary, right? So within a certain parameter space and design space, it's not rigid as a jig. It actually can execute the same path, let's say, but with a different underlying to create a different underlying geometry or feature set. So that gives us really the fundamentals that we need is repeatability, robustness, quality control, adaptability, and speed, right? So that's what mattered for us when we decided on robotics, and so now we spent many years to develop all the surrounding technologies to make sure it's functional.
What are the sort of hurdles to adoption and or sort of non-negotiables in your way of designing data in traditional construction to sort of make this workflow work, or just maybe it is a slightly different question, but what are the sort of hurdles to adoption right now of what you're going through?
Yeah, there are many, right? I mean, when you really change the model, and we are, right? I mean, just to be clear, we're going from a service-based industry to a product-based industry. And when you really take that to heart, it means we're not doing the typical design build process, but we're rather saying people can come to us and they can order a building from us. And we integrate, with our clients and their needs as much as we can. But the net effect is that you can't delay questions about component design and procurement until the very end and see who the lowest bidder is. That just doesn't work. When you productize and industrialize our industry, which is when you use something like mass timber, you almost have no choice but to, because it's not a material that's very forgiving to change it on site, right? I mean, you have large scale components that need to be precision manufactured and essentially just assembled. So that means you have to bring the team together right from the beginning. And so one of the big hurdles is, in the way how the industry right now works, is the procurement processes everywhere are still in the old model that you do basically a late tender to a lower bidder, and that just needs to change, where you basically have an early tender and qualify the participating parties as a team that can deliver buildings. And that's a massive hurdle because our industry is deeply entrenched in its ways, and it changes the way how even the players in the industry can participate. Architects, structural engineers, builders, etc. Right? So everybody around us needs to that want to participate with us need to also change and adapt their business models, because yes, we can provide them with far more scale in what they want to do, but their typical ways also don't work anymore. So you have to change the mentality, you have to change the business models, and that takes time, and it's a significant effort to do so. Secondly, it's the regulatory framework, of course. Fortunately, in North America, that's come around finally. So we're allowed now to do mid and high rise up to 18-story timber buildings in North America. And there's a regulatory framework, so that gives us a lot of certainty in a way that we actually never had before, which is great, that you have sort of almost a unified building code around high-rise mass timber and a building science. So that's definitely gone from a major hurdle to an enabler, which is great. And it's I think it's sort of mindset, like risk tolerance. It's new, it's different, and so people think, okay, is it more risky because they haven't seen a lot of mass timber buildings, they haven't seen buildings that come out of factory of parts that are assembled by robotics, and they need to get comfortable with it. So whenever you introduce a change, a technological change, a design change in an industry that's truly disruptive, obviously, everybody says, how many buildings have you built? Right? And our answer to that is, we've built a few, but really we spent most of the time right now to get through everything to ramp up the factory, to get the testing done, to get the component definitions done, to make sure that we have a really robust solution. So these are hurdles. It's typical for I think when you have a introduce a change into a very entrenched industry.
Well, it sounds like because you're going the product route, it's like the Honda of the manufacturer of the first car. There's a lot more effort and time that goes into the product, which can be scaled up millions of times. And it sounds like you've done that process end to end, and now you're at the position potentially where you can scale it out. The productization you've done to a lot of buildings. Is that the way you see it?
Yeah, that's what it is, and I mean there are other industries that you could cite where that's happening, right? Where you see a fundamental shift in how products are conceived, designed, and manufactured, and then delivered out in the market, and it just takes a few years to get everything ready for it.
Yeah, that's so cool. One of the issues in construction, of course, is the changing costs and the uncertainty around that, and it blows out and everyone starts pointing fingers. Do you offer, or is the plan to offer cost certainty from the very start, so sort of like a buy now with certainty in delivery and costs and everything like that?
Yeah, totally. I mean, I think that's the advantage we have, is because through our software, for example, we can quantify within a matter of days or weeks, where others may take month and month. We can come back to a client saying, this is exactly how much timber's in the building, this is how much insulation's in the building, this is how many windows, and so forth. So not only when you have a good definition of geometry and physics of a building, you get good quantity that reads out in carbon, that reads out in cost, and so forth, right? And so you can apply rates to it, and so we can provide much more certainty to this. I think the realization that we have is really that we have to even go further, because with what's happening in the world right now, with inflation and so forth, the remaining part of on-site construction is still seeing a lot of inflation. But our parts have been, at least our components have been very cost stable even over the last 2-3 years, right? So. But that's, to answer your question, yes, you can provide far more guidance and cost certainty right from the get-go because of the level of integration that we can offer.
Yeah. One of the things that seems critical is the standardization and the benefits of that. But then you've, for the devil's advocate hat, it's around the maintaining architectural flexibility and some sort of creativity in design and like that. So how do you see managing those two? We could arguably competing interests, or how do you handle that?
No, I think it's an excellent question, because when we started out, we looked, of course, into the history of prefabrication and what's been done, and prefabrication is not new. People have done modular buildings over 100 years ago, and but they never really took hold. And I think from our analysis, what's shown is we have an industry right now that builds predominantly bespoke buildings, right? It's a one-off, right? And it's a complete custom, and that has all its maybe somewhat benefits, but really mostly disadvantages in cost escalation and all. Basically every building is a prototype, right? That's really mind-numbing to some extent, that we really haven't learned. On the other end, we have seen prefabrication, and it became sort of like the one fits all, right? It complete normative in a way, like stacking boxes, volumetric prefab, and so forth. That works, for some projects, but the vast majority it doesn't work for, because the demographic needs are different. The needs on a particular location and a particular site in cities, in Melbourne might be different from Vancouver, but there are also equally similarities. Housing is housing. We all like, something that we call home. We like a connection to the outdoors and so forth, right? So we identified where there are similarities and where we need a degree of flexibility that allowed to a creation of resilient communities, and something that people can really identify with, and that works within the scale of development. And that creates sort of the design space, right, in which we have to have required flexibility. So, we want to be simple and efficient and create a beautiful product, but we also need enough adaptability. And so we went back and forth. And this is sort of where this combination of technology is very powerful, because in software, you can design everything parametrically, which we've done. So we can go in and saying, let's change the unit mix, let's change the depth, let's change the window ratios, let's change the width of a home, the livability issues, the adaptability over time, the connection indoor, outdoor, and so forth. You can parametricize all that while always ensuring it's manufacturable, right? And then on the other end, you've got the robotics. And as I previously mentioned, when you manufacture something that you know have tested and you know, okay, I know what my structural spans are that I can maximum achieve, but I can make it a little narrower, I can make it a little longer, I can have a longer span, a lesser span, and so forth, right? I can set systems here and there. I have a design space in which I can flex. And there's enough there that you can now manufacture, or we can manufacture, basically a whole range of buildings from 4 to 18 stories, from rental to condominiums, from commercial users all the way through office users to residential users, all from the same manufacturing lines, based on fully tested and certified components, right? So the flexibility, the adaptability, or the mass customizability has been built into the technology ecosystem from day one.
That's so cool. Where do you see the puck going in the next 5 years with all these new technologies, and not just Intelligent City, but the whole ecosystem in general?
Great question. I would say what we recognize, or what we realize, in at least in Canada right now, we have a major housing crisis right now. We have a major global crisis in financing, in inflation, cost, and so forth. So, and we have a climate change, major climate change issue in the world. So when you put them all together, what's happening is that maybe 5 years ago, responses have been, let's say, aspirational at best. What's happening now is the regulation is changing very rapidly, that in many jurisdictions in Canada, basically, you have to now demonstrate that your buildings are life cycle carbon neutral. And that's very, very difficult to achieve with the typical forms of concrete construction and low performing buildings with a lot of thermal bridging and low insulation values and so forth. So the performance requirements, the environmental issues are required to really improve substantially, while at the same time, where's the funding coming right now? Housing needs to be built. The cities have no choice. So a lot of it is now funded through federal funding, provincial fundings, et cetera, and housing programs into rental. So I think a lot will go into buildings that are about rental, that have a really good life cycle performance, that have to demonstrate far more longevity, with low maintenance costs, low operating costs, not buildings that last 30 years and need to get demolished. You have a massive loss of capital if you have to rebuild your buildings every 30 years. So buildings need to be flexible. They need to ensure resilient communities. They need to be carbon neutral, and at the same time, cost effective. And I think that's the driver right now, not just for what we do and what we got ourselves ready for, but I think where our industry sort of inevitably has to go, because these are the problems that we need to solve collectively.
Yeah, that's a phenomenal answer. Well, it's been great being able to speak to you, Oliver. If people want to find out more about yourself and what you've been working on, where should they go?
Well, you can come to our website at intelligent-city.com. And there's a lot of information there. And of course, by all means, always, if anybody's interested, you've got an interesting project to work with, or you want to collaborate with us in any forum, then yeah, please reach out to us. It's all the information on our website, and we're looking forward to be active in many parts of the world. And if there is a great project somebody wants to realize in Melbourne, we'd love to participate.